Today we're going to talk about polynomials. We're starting a new chapter, and we're going to be able to classify polynomials and identify, evaluate, add, subtract, and multiply polynomials. Okay, some vocabulary that we need to be aware of. And the word monomial. That means that there's one term. Mono means one. An example of a monomial would be 5, 2x. So even though there's a 2 and an x, they're combined through multiplication, so that counts as one term. Similarly, 7x squared y squared is also a monomial. It's not being broken up with addition or subtraction. A polynomial means that there's more than one term. Okay, and that means that the terms are broken up by addition or subtraction. So an example of a polynomial would be x plus 2. Another example would be 3x squared plus 5x plus 6. The degree of a polynomial refers to the highest exponent. And so an example would be if I have 5x to the 7th plus x to the 6th. My highest exponent is a 7. So my degree here would be 7. Okay, so for all the functions, okay, for the first function, what would be the degree? So it's 2. The second function, 3. The third function, 1. And the last function, 8. Write the polynomial in standard form. So when we talk about standard form of a polynomial, it is in order from highest to lowest exponent. So just like with quadratics, we had the x squared first, then the x term, then the constant term. And so it goes from highest to lowest exponent. So we're rewriting the first one. So we're going to put the x squared first, then the minus x, then the plus 2. And the next one, what's going to go first? Negative 3x cubed plus 5x squared plus 15. And the next one, we're going to put the 3x to the 7th first. And the 12x to the 4th. Then the minus x, then the minus 1. And the last one, 4x to the 4th goes first, minus x squared plus 6x plus 25. And those are all standard form. Now the way you classify a polynomial is by using the degree and the number of terms. So here's some examples. We have names for degrees between 0 and 5. So if the degree is 0, it's a constant. If the degree is 1, it's a linear. If the degree is 2, it's a quadratic. If the degree is a 3, it's a cubic. The degree is 4, it's quartic. And the degree that's 5 is a quintic. If the degree is higher than 5, we just say it's a 6th degree polynomial or it's a 10th degree polynomial. The number of terms, we know the words for 1, 2, and 3. So if there's only one term, it's a monomial. 2 terms is a binomial. 3 terms is a trinomial. Anything after 3 terms, we'll call a polynomial of that many terms. So if there's 10 terms, it'll be a polynomial of 10 terms. So we're going to write each polynomial in standard form. It's very important that you write it in standard form first. If anything can be combined together, it's going to change your classification. And then we're going to classify by degree and number of terms. So in the first example, first we put it in standard form. So we're going to have 5x to the 4th plus 3x cubed minus x. And the highest degree is a 4. So the degree always goes first. So since the degree is a 4, this is called a quartic. And since there's 3 terms, it's a trinomial. So this is a quartic trinomial. In the second example, we're going to put a negative 4x to the fifth first, then the 2x squared. But we have a 3 and a 10. They can combine together and give me 13. So now we've changed this from having 4 terms to 3 terms. Okay, so our highest degree is a 5, so it's a quintic. And then it's 3 terms, yes. So it's a trinomial. Okay, so if you didn't combine the 10 and the 3 together, you would say that it's a quintic polynomial of 4 terms. But that would be incorrect, since you can combine your like terms and simplify this. When you're adding polynomials, you treat them just like any other adding and subtracting. So you're going to find your like terms that go together, and you're going to combine your like terms, and then write your answer in standard form. So if we look at this, I like to do it in standard form from the beginning. So I'll look for the highest degree. So my highest degree in the first example is a 3. And that's that negative 4x to the third. There's no other x to the third, so that's going to be first. After x to the third, I have x squared. So I have a 7x squared, and I have a 9x squared. And I'm adding. So when I add them, I'm going to get 16x squared. Then I have my x terms. So I have a 9x and a negative 9x. So when I combine them, they'll cancel out. And then I'm left with a negative 5 and no other constant. So that's going to be minus 5 at the end. Okay, so there's my answer in standard form. And if I wanted to be fancy, this would be a cubic because the degree is 3. And it's a trinomial. Okay, in the next example, same idea. So look for your highest degree first. So my highest degree is a 4. So I have negative 5x to the fourth and positive 3x to the fourth. So it's going to give me negative 2x to the fourth. Then I have negative x cubed plus 6x cubed. So 5x cubed. And then I have 4x squared and negative x squared. Positive 3x squared. And then there's no x term in either of them, so I'm going to skip that. And then I have a 9 and a 12. So that's going to give me a 21. So now that's in standard form. And again, if I want to be fancy, the degree is a 4. So it's a quartic. And there's 4 terms. It's a quartic polynomial of 4 terms. Okay, so here's some examples that you guys can try on your own. What you're going to do for these is just match the functions that they show you. So f of x plus g of x, you're going to use f of x plus g of x. So just to set it up, you have negative x plus x squared plus 2 plus 50 minus 3x cubed plus 5x squared. So you're just matching the two functions that are at the top, and then you're just adding them together. Okay, with subtracting polynomials, it's the same exact idea as adding. You just want to be careful of the negative. So again, if you want to change the minus sign to a plus, and then change all the signs in the second expression, you can do that. So again, I'm going to look for the highest exponent. So negative 4x cubed. There's no other x cubed. So there's really like a 0x cubed over here, since it's not over there. And then I'm subtracting a negative 4x cubed. So I'm going to end up with a positive 4x cubed. Okay, so now we're going to look at the x squared term. So I have a 7x squared, and I have a negative 9x squared. So I'm going to do 7 minus 9, and I get negative 2x squared. And my x terms now, I have a 9x, but I'm subtracting a negative 9x. So that's going to become plus 9x. So now I have 18x. it stays negative 5. Okay, so here's my answer in standard form. And then again, if I want to be fancy, this is a cubic. And there's 4 terms, so polynomial of 4 terms. Okay, so second example, same thing, just make sure that you distribute your negative to everything. Okay, and then again, some examples that you can try. Just matching the functions at the top. Okay, when you're evaluating polynomials, that means that you're going to plug the x in and solve. So to evaluate f of x when x equals 2, what we do is we're going to plug in 2 for x. So 7 times 2 squared plus 9 times 2 minus 5. So the left side, the f of 2, we don't do anything with that. That's going to be our answer. We're just evaluating the right-hand side. So 2 squared is 4. So 7 times 4 plus 18 minus 5. So 28 plus 18 minus 5. So 46 minus 5 gives me 41. So f of 2 is 41. And we're going to do the same thing now with negative 1. So we're going to plug in negative 1 for x. So 7 times negative 1 squared plus 9 times negative 1 minus 5. So that's going to give me 7 times 1 minus 9 minus 5. So I'm going to get negative 2 minus 5, which is negative 7. Okay. And then here's some examples that you guys can try. You're going to plug in, match the letter, and then plug in the x value, and then solve.